I think is the using the lecture using PowerPoint about lactate formation and mitochondrial shuttle is not really easy to understand, is right? Yeah, especially if you do not have any biochemistry, general and organic chemistry background, it'll be tough. It'll be tough. Yeah, but actually that is a really good lecture using the PowerPoint. But today I want to use this board, so it'll be much easier to understand. And actually I want to simplify the reaction, but still it's important for your quiz and exam. I believe it will cover all of them, right? So today lecture using the board. So during exercise, you need energy, right? That energy from where? From ATP hydrolysis. So ATP hydrolysis, and here I would like to write down to use energy from ATP, we must add water, right? So water, and we need enzyme. This case ATPase, is it right? And it's become how about ADP, inorganic phosphate, and proton. Does it make sense? Doesn't make sense? Yeah. And another one, when we start exercise, we need a creatine phosphate, is right? This case, creatine phosphate is here, and this proton from here, I think you remember, is right? It's become creatine and what is this? ATP. Right? So we resynthesize ATP. Is correct? Is correct? Right? And how about after 10 to 15 seconds, we do not have any more creatine phosphate. So we have ADP accumulated, and using 2 ADP is make AMP as well as ATP. So we resynthesize ATP from this reaction. Is it right? Could you see? Okay, how about like this? Yeah. How about class? Doesn't make sense. So I do not need to write down its AMP DMS reaction is here, but this AMP is important. Is it right? It's activator of glycogenolysis and glycolysis. Right? Right? Yeah. So, and after phosphatic system, or actually, yeah, if we start exercise, this AMP is activate glycogenolysis and glycolysis, depend exercise intensity. Exercise is a little bit lower, that case glycolysis. Exercise higher is glycogenolysis, is right, AMP. And we talk about glycolytic energy system in the blood, right? How about this is blood? This is blood. There are glucose, is right? And how can we put the glucose in our muscle fiber? Hexokinase reaction. So put the glucose molecule, we need hexokinases. How about this is not glycolysis, lecture, so I want to really simplify. Right? And in the muscle, there are glycogen, is right? And this glycogen has need inorganic phosphate, is right? And become glucose 1-phosphate, is right? And become glucose 6-phosphate. And this case, glucose to become glucose 6-phosphate, hexokinase use ATP and become ADP using inorganic phosphate from ATP and make glucose 6-phosphate, is right? So right now, glycolysis, glycogenolysis share same pathway after glucose 6-phosphate. Does it make sense? Does it make sense? Yeah. And glucose 6-phosphate, just little arrangement, fructose 6-phosphate, and it's become 1,6 bis phosphate, is right? Oh, fructose 1,6 bis phosphate, is right? Is right? Which enzyme? Actually, PFK, is right? So after PFK is become, there are some reaction, but simply is G3P, right? Glycerolaldehyde 3-phosphate, but G3P. It's become DHAP, but and become G3P, but you already know it, right? Just I wrote down G3P. So this is step 6, right? Step 6 is a really important step. Did you remember, right? And there are some like a move like this, right? And become pyruvate, right? This is glycolysis, is right? And how about class? Did you remember? During phosphatic system, AMP activate which one? AMP activate, oh, I forgot. Here, phosphorylases. So AMP activate phosphorylases, so it means activate glycogenolysis. And AMP activate PFK, so it means it activate glycolysis. Does it make sense? Does it make sense? Yeah. And step 6 is important. Step 6 is important. So, and another one is pyruvate as a product is important too, because there are metabolic pathway, is right. It's a metabolic pathway. It's not only straight, right? There are metabolic pathway. See, it's like this, right? This metabolic pathway. Glycolysis, the product is actually, please watch here, pyruvate as well as step 6. Step 6, it release 2 proton and 2 electron each side. Each side. Here the same. It release 2 proton, 2 electron. It's okay. It's okay. Yeah. So 2 proton, 2 electron, right? We do not like hide a proton, right? Proton, because it's make acidosis. It's metabolic acidosis. So it should go somewhere. Is it right? So if some molecule like oxidize is release proton to electron, can you guess which one to come? Metabolic Uber taxi. Metabolic Uber taxi. Enzyme, coenzyme. Coenzyme, right? So G3P release 2 proton, 2 electron. We need metabolic Uber taxi, that is NAD plus. So it released 2 proton, 2 electron, NAD plus to come and to get 2 proton, 2 electron and become NADH plus proton. Wow, that's sense. NAD2 is reduced, become NADH plus proton. Here too, right? So this is step 6. Step 6 is important step, right? So G3P release 2 proton, 2 electron. So this is why NAD plus to come and to receive 2 proton, 2 electron, and it's become NADH plus proton. Does it make sense? Yeah. So glycolysis is product is not only pyruvate, the product is NAD plus proton, NADH plus proton. This is product too. Is it right? Class, did you remember mass action effect? Mass action effect, which was really important. Did you remember? That is concentration is right, right? If concentration of concentration, high concentration go to the less concentration, is right? So this is why we can go to our reaction. But this case, NADH plus proton, if this is accumulated and pyruvate is accumulated, this case, based on mass action effect, this glycolysis cannot continue. Glycogenolysis cannot continue if NADH proton and pyruvate are accumulated, is right? So it should go somewhere. So at rest or during steady state exercise, intensity exercise, it means relatively low exercise, low intensity exercise. It's go to the mitochondria. How? Please watch here. This is mitochondria. You know, mitochondria is double membrane, is right? So outer membrane as well as inner membrane, is right? So we call outer membrane, inner membrane, this space, intermembrane space, and here is matrix, right? Mitochondrial matrix. So relatively low exercise intensity, and I think I can use different color, right? So at rest, relatively low intensity exercise, NADH proton through the shuttle, but I want to simplify through the shuttle, right? So these 2 proton and actually 2 electron too, is right? Even I write down here, you just imagine there are electron, right? Is electron is here. Yeah, it's textbook is even my PowerPoint. We actually I did not write here, but you just imagine there are electron, is right? So these 2 proton, 2 electron should enter in the mitochondria. And how about class? Why these 2 proton, 2 electron should enter mitochondria? Can you guess? Are there anything is waiting for these two proton, two electron? Can you guess in the mitochondria? Yeah, there are something is waiting for this one. Mitochondria has some thing, some system that is electron transport system, right? Yeah. So ETC system, right? So ETC system is waiting for this electron, this proton, especially this electron. Doesn't make sense. So this is why these two proton, two electron should enter mitochondria to the ETC system. Is right? Is right? Yeah. But it cannot go himself, so, themselves. So this is why we need coenzyme NAD plus. How about is very reasonable? Dr. Gon call is Uber taxi, is it right? Uber taxi, right? So these two proton electron go to the inner membrane space, right? To give this proton to electron and become NAD plus. So NAD plus is kind of a substrate. NADH plus proton is a product, right? So we have substrate, so we can continue. Glycolysis can continue, is it right? These two proton electron, based on our lecture, which coenzyme receive that one? NAD plus. This is a skeletal muscle, FAD. FAD reduce FADH2, receiving two proton, three electron. Is it right? And can you guess FADH2 go to where? FADH2 go to where? Yeah. Go to ETC system, right? It's go to ETC system, right? Give protons, give electron to the electron transport system, right? Yeah, it really makes sense, right? Really makes sense. And relatively low intense exercise, and at rest, this pyruvate directly enter in the mitochondria matrix. Is okay, yeah. So at rest, relatively low intensity exercise, NADH plus proton give two proton, two electron to the mitochondria, especially FAD, and pyruvate directly enter mitochondria. That's it. That's it. At rest or relatively low intensity exercise. Class doesn't make sense. Doesn't make sense. Yeah. And another one. How about class? What's here? So actually, glucose 3-phosphate, right? So it need inorganic phosphate. Class, did you remember? If you didn't remember, please watch. Please watch is our glycolysis. What is this lecture? Lecture. Right? And we need ADP here. We need ADP here. We need ADP here. We need ADP here, right? Because we can resynthesize ATP, right? After phase one, phase two, we get 4 ATP, is right? To do this one, we need ADP, right? And to get a more ATP, we must add inorganic phosphate. Actually, first glycogen they did, right? And glucose phase one and hexokinase PFK, they add inorganic phosphate, is right? And after phase one, phase two, right? We have a inorganic step 6. We must add inorganic phosphate, and we must add ADP here, right? Can you guess where from this inorganic phosphate for ADP, right? So this is glycolytic system, is right? So relatively still low exercise intense, but still intensity exercise, right? Like even jogging and running, right? Keep exercise. This ADP inorganic phosphate from is here. ATP hydrolysis, right? It means if you stop exercise, no more ADP inorganic phosphate. So this case, we do not have any substrate particles here, right? So glycolysis just stop. But if you keep exercise, right? So we must break down ATPs, right? So ADP inorganic phosphate proton are accumulated. So this is why we can use ADP from here, and this inorganic phosphate from here. Does make sense? Makes sense, right? Relatively low exercise intensity during relative low intensity exercise is go to the mitochondria. But how about strenuous exercise, high intense exercise, high exercise intensity exercise? This pathway is blocked. This pathway is blocked. high intensity exercise, during high exercise intensity, why? Sometimes people, because exercise is too high, or some people are not trained, so they have less mitochondria and do not functioning well mitochondria and small mitochondria. How about class? Doesn't make sense. Like that case, yeah, this pathway is blocked. So this case, how about if you want to keep exercise, it should be glycolysis can continue, right? This case, please watch here. So this one is a block. So this case, this NADH plus proton is accumulated. This case, glycolysis should stop. So this case, and how about this NADH plus 2 proton and 2 electron and give to the pyruvate. And this pyruvate become lactate. Wow, lactate is good, right? Because lactate consume these 2 proton and 2 electron. How about, does it make sense? Doesn't make sense, yeah. So this case is consumed, and as well as is right now NAD plus is free, right? So NAD plus can go back to the step 6 to get more proton, more electron. How about right? It's good, is right? It's good, right? So lactate is here. So we just solved the problem. During high intensity exercise is blocked. Pyruvate cannot enter mitochondria. NADH plus proton cannot give 2 proton, 2 electron to the FAD. So at that time, this time, NADH plus 2 proton give 2 proton, 2 electron to the lactate. I'm sorry, pyruvate. So pyruvate become lactate, and NAD plus is available. So go back to the step 6 to get a more 2 proton, more electron. Is it right? Does it make sense? Does it make sense? Mm-hmm. Yes. So class says, how about is here, right? So and another one. So it means during high intensity exercise, lactate is important because we can continue glycolytic energy system, right? The problem is because based on mass effect, right? If we have more product is here, could you see? Yeah. So our reaction stop is right. This reaction cannot go to the because we have more concentration of product. Is right? Is right? So this case, this lactate should be out of the muscle fiber to the blood. So how about lactate is must go outside the blood? See, if lactate is out of the muscle, there are no lactate, so we do not have any product, so concentration is smaller, so glycolysis can continue. Is it right? Is it right? Yeah, is it right? So during high exercise intensity, we can find lactate in the blood. Class, does it make sense? Yeah. But another one is there are some kind of shuttle, specific protein, some shuttle. The usually we call just abbreviation is MCT. Yeah, MCT, monocarboxylate transporter we call, but MCT. So this MCT is very interesting. Please watch here. And lactate I can rewrite simply and LA, right? Lactate, and this lactate is negatively charged. Lactate is negatively charged. So when this negatively charged lactate go outside, we need positive charged molecule go outside with lactate. And this shuttle, this case, lactate go outside. Can you guess which one go outside with lactate is perfect? Positive ion. Yeah. This proton. During the ATP hydrolysis, this proton go outside from the muscle with lactate. So during high exercise intensity, we can find lactate at the same time proton. Wow, does it make sense, right? So long times ago, scientists found during high exercise intensity, they found lactate and proton. And can you guess what they named this one? They believe, oh, during high exercise intensity, body release lactic acid. Like this kind of approaching, right? Yeah, but that is not correct because this lactate from during high intensity exercise to continue glycolysis and lactate release, is it right? And at the same time, proton from ATP hydrolysis and release from the muscle to the in the blood with lactate. So we must say during high intensity exercise, but we have lactate from glycolytic energy system and proton from ATP hydrolysis. We cannot say lactic acid is right. And even science, right, couldn't really, there are no evidence. We human body release lactic acid, but we release lactate. So this is why I mentioned about our lecture. Wow, there's many exercise textbook. Well, if you just type the lactic acid in the Google searching engine, still some article they still talk about lactic acid. Right? This is why it's not really correct. It's correct. It's not really correct. So summary, right? Glycolytic energy system, right? The product are pyruvate and NADH plus proton. At rest or relatively low intensity exercise, and a pyruvate can enter in the mitochondrial matrix, and NADH plus proton, right, and give 2 proton 2 electron to the FAD and reduce FAD to FADH2, is right, and NAD plus proton is become NAD plus and can get more proton, more electrons, right? So it's right there. So this is why glycolysis can continue. However, during strenuous exercise, high intensity exercise, right? High intensity exercise, so it blocks. Or someone who do not have like a trained their mitochondria, trained muscle, right? No less mitochondria. That case, this is blocked. So we need another metabolic pathway. That is from the step 6, NADH plus proton, it gives 2 proton, 2 electron pyruvate, and pyruvate become lactate. And finally, NAD plus are available, so go back to the step 6 to get more proton, more electron. Does it make sense, right? And this lactate, it should be get out of the muscle fiber based on mass action effect to continue this glycolytic energy system, is right? But lactate go outside through the MCT, right? MCT, but the MCT is interestingly and release lactate at the same time proton, right? Proton and lactate released at the same time. Finally, in the blood, we can find lactate from glycolytic energy system and proton from ATP hydrolysis. Does it make sense? Okay, so please don't never say that lactic acid. That is not correct. And another one, lactate is really, really good. It's really, there are a lot of another function too. But just based on this understanding, is many times if you would find some kind of video about lactic acid in YouTube or social media or Google, right, searching engine, they believe it's lactic acid is like waste product, like burning product, right? No, that is not correct. Lactate is important. It's an important thing, right? Doesn't make sense. And there are a lot of another function too. So maybe during the class I'll talk about this one. So how about class? I think good is right. Any question, please post it or give the question to our question and answer discussion section. Right? Class doesn't make sense. Or you can send email to me. Thank you very much.